Hi, welcome to my video on the conditions of continuity, and this is number 2 video on the conditions. So let's go through some examples to show you if it's continuous at a point. Number 1, the h of x equals the square root of x minus 6. Is the h of x continuous at x equals 2? So the first condition is that the h of 2 is the square root of 2 minus 6. That's the square root of negative 4. Square root of 4 is 2, and the square root of a negative number is an I. So that means it doesn't exist. It's not defined. It's not a real number. So it's does not exist, or we could say D and E, the limit does not exist. So because it's not true here, that means it's not continuous at x equals 2. And again, the limit of f of x as x approaches 2, the limit does not exist because it's an imaginary number. So it's not defined, so the limit is not continuous. Number 2, the f of x equals 1 over x plus 3. Is the f of x continuous at x equals negative 3? Again, condition A is the f of negative 3. So we sub in negative 3 plus 3. That's 1 over 0. And 1 over 0 is, that means it's undefined. It's not defined. So what it means that when x in your graph, if you think about it, in your graph as x equals negative 3, which is right here, it's a vertical asymptote. So it's, you can't have negative 3 in this rational function, because it's a vertical asymptote at x equals negative 3 because it's undefined. So that means it's not defined, or it does not exist. So it's not continuous at x equals negative 3. So it broke down in the first condition is not defined. Okay, let's do some more. The p of x is equal to 4 when x is 1. The p of x is equal to negative 2x minus 4 when x is greater than 1. And it's equal to x plus 2 all squared when x is less than 1. So is the p of x defined at 1? Well, the first condition is the p, oh, not f, this is the p, sorry about that. The p of 1, is it defined at the p of 1? The p of 1 is a 4, so it's defined. That means it exists. Okay, B part. Now we do the limit of the p of x. We're going at x approaches 1. Let's approach 1 from the positive side. So we approach 1 from the positive side. That means we have the limit of, as x approaches 1 from the positive side. Positive side is greater than 1, so that's negative 2x minus 4. And that gives you negative 2 bracket 1 minus 4. So that's negative 2 minus 4. That's negative 6. And what about the limit of the p of x as x approaches 1 from the left side? And that means if you approach from the left side, x is approaching from the left side, that means that's less than 1. So we have x plus 2 all squared. So it's approaching 1, so it's 1 plus 2 squared. That's 3 squared. So that gives us a 9. So note, the limit from the right is -6. The limit from the left is a 9. So that means the limit of the p of x as x approaches 1 from the right side is not equal to the limit of the p of x as x approaches 1 from the left side. They're not equal, so therefore condition failed. A is true. A is true. The p of 1 is 4, but the left and right side limit are not the same, so it's not continuous at, and we said at x equals 1. Broke down in the second condition. The limit on the left is not equal to the limit on the right. Okay, let's try another one. Number 4, the v of x. The v of x again is a piecewise function, and when x is greater than -2, we have an x plus 5 linear. When x is equal to -2, we have a 1. When x is less than when x is equal to -2, we have a 1. When x is less than -2, we have the square root of -2x, add on 1. So is the v of x continuous at x equals -2? So A, the v of -2. So the v of -2 is here, so that means we got a 1. So it's defined. So because it's defined, it means the limit exists. Now let's look at the limit of the v of x. As we approach, we're approaching, x is approaching -2. Let's go with the right side again. And that means if we go with the right side, and let's see, the limit, this is the right side, so this is an x plus 5. So if we put as a -2, so it's a -2 plus 5, so that gives us a 3. Again, seems like 3 must be my number. What about the limit as the v of x approaches -2 from the left side? So this is the left side, less than. So we have the limit of the square root of -2x plus 1 as x approaches -2 from the left side. That should be underneath here. So that gives us square root -2. X is approaching -2, so it's a -2 plus 1. That's the square root of 4 plus 1. The square root of 4 is 2. 2 plus 1 is 3. So the limit, the v of x on the right and on the left, both of them are 3s. Again, apologize. I made them all 3s. I should have scrutinized it a little bit more careful, but I just noticed it. So that means the limit of the v of x as x approaches -2 on the right side is equal to the limit v of x, let me put a bracket there, as x approaches -2 on the left side, all equal to 3. So that means the limit of the v of x as x approaches -2 is 3. Okay, now what do we see? But the limit of the v of x as x approaches -2 is 3, but that's not equal to, notice it's not equal to the v of x, or the v of -2. So they're not equal. So hence, it's defined. First step, both left and right limits are 3s, but where it's defined at, -2 gives you 1. So they're not the same. So that means it's the v of x is not continuous. at x equals -2. So again, the conditions are, it has to be defined. The left and right limit's got to be the same to make the limit of the v of x be that limit. And then where it's defined and the limit both have to be the same. But in this case, where it's defined, you get -2 gives you 1. This is a 3. 1 and 3 are not the same, so it's not continuous. So again, 3 examples where it's not continuous. The other examples I did in the first video where it was continuous. So that brings us to the end of this video. And if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.